Hello and welcome to my YouTube channel. In this video, I am going to explain how to draw a shear force and bending moment diagram of a beam having UDL on its entire length. As you can see in a diagram, we have a beam with the UDL 3 kN per meter acting downwards, and we have three steps to follow: reactions, shear force diagram, and bending moment diagram. So first of all, we will calculate reactions. So the reactions are very simple. As you can see, the load is 3 kN per meter over the length of 4 meter. So the total load, we will calculate total load is equal to 3 multiplied by 4. It will be 12 kilonewton. So 12 kilonewton is acting downwards on our beam. So now reaction at RA is equal to reaction at RB. So this is somehow symmetrical beam. 12 divided by 2 is equal to 6 kilonewton. So we have B is equal to 6 kilonewton, and also we have A is equal to 6 kilonewton as well. Okay, based on these numbers we can draw our shear force diagram. Okay, so how do we draw our shear force diagram? At RA, reaction at RA is 6 kilonewton. So we will go 6 kilonewton upwards. Then we have a center point. Now we have to think about it carefully. We have 3 kilonewton over the span of 2 meter and also over the span of 2 meters. So altogether 4 meters. So 3 multiplied by 2 is equal to 6 kilonewton. The 6 kilonewton is in the form of UDL, and this UDL is influencing our beam to go down, to act downward. So what it will do, because this is a UDL beam, this is a beam with the UDL, so the shear force diagram would use diagonal lines. So it will come down gradually to point C in the middle. So it was 6 kilonewton upwards. So because the load is pushing our beam downwards gradually, so we will come down in the form of diagonal line. So again, the load hasn't stopped yet at point C to point B, is still coming down. So it will make our diagram like this. Once we get to this point, because this is a 6 kilonewton acting upwards, so we will join our line. So this is 6 kilonewton upwards, and this is also a 6 kilonewton. So this is how you can draw your shear force diagram for this type of beam. So this is positive zone, and that's we have a negative zone. Okay, now let's draw a bending moment diagram. Before drawing a bending moment diagram, we have to calculate bending moments at each point. Okay, so bending moment at point A. So we have 6 kilonewton upwards. It doesn't have any arm, so it will be 6 multiplied by 0 is equal to 0. So at point A, at point start and at point end, if we get 0, then it means our diagram and our calculation is correct. Okay, so bending moment at point C. Now we have to see how many loads are acting on our beam to get to point C. We have one point load, another is UDL. So what it do? 6 multiplied by 2, because from A to C is 2. Then minus, we have another load which is UDL. So it will be 3 multiplied by 2 multiplied by 1. Why is 1? Because UDL always acts on in the middle of its length. It doesn't cover whole length of the beam, for example. So the distance would be half while multiplying with the UDL. So it will be 12 minus 6. It will be plus 6 kilonewton. Okay, now bending moment at point B. 6 multiplied by 4. Okay, because from A to B the distance is 4. Then we have minus this UDL, which is 3 multiplied by 2 multiplied by 1 in the middle of the length, for example, the span, which is 2 meter. And then we have minus again this part of the beam, which is also 3 kilonewton over the span of 2 meter. It will be 3 multiplied by 2 multiplied by 3 again. So 1 is from 2 from here and 1 from here, so it will be 3. 24 minus, we have 6 minus 18, so at the end we will get 0 kilonewton. At point A is 0, at point C is also, at point B is also 0 kilonewton. So on base of these numbers we can draw our bending moment diagram. Okay, so at point A it's 0, at point C, which is in the middle of our beam, so which is positive 6, so it will go somewhere up here, and at point B we have 0. Now while drawing bending moment diagram having UDL on our beam, the type of line which we will use to draw our bending moment diagram will be a curved line. So okay, so how I will draw it? I will draw it something like that. That's how you can draw your bending moment diagram for this type of beam. So obviously this is in positive zone. I hope you have understood what I have explained. That's it for today. Thank you for watching my video. Please don't forget to subscribe my channel.